Welcome to lesson 87, and today we're talking about multiplying algebraic terms. Last time when we talked about algebraic terms, we were breaking things down into different kinds of polynomials, and then we talked about how those like terms can be added together. So we had a sample problem very similar to this, and we got an understanding that I could take this 3x and I could add it to this 2x and get an answer of 5x. And that relationship works because of the principles of mathematics. And we use this example, something like this, to prove that why that would be true, because that's the same as 7 times 2. Right? So we looked at that idea. Well, that was addition. Now we want to think about multiplication and how multiplying algebraic terms is different. And some people find this step easier. It seems to make more sense to them. Other people don't. Right? But let's take a look at what we're going to do here to solve this problem. So our problem here is 3x times 2x. And so this time we're taking an idea and we're not doing repeated addition. We're doing repeated addition of just one value, but we're doing 2 terms worth of repeated addition, which when we talk about it that way, it gets a little bit confusing. So it's better just to kind of just stick with it and talk about how to do this process. To solve this, what you're going to do is you're going to take your coefficients and you're going to multiply the coefficients together. 3 times 2 gives us 6. Then you're going to take your variables and you're going to multiply those together. X times x. X times x, we would say, is x squared. And so in the end, 3x times 2x gives us 6x squared. So now that we've covered the basics, let's jump into this a little bit more, throw a few more variables at us, and talk our way through how to solve a slightly more complex problem. Now, if you look at this problem, you might say, wow, this is way more complex. But really, if we follow the orders of operation and group the parts that kind of work together, our variables that are the same, we're going to come away with a step-by-step process that's going to help us solve these problems. So, to start, because it's multiplication, we're multiplying everything together. And so to do this, what we want to do is we want to find things that are the same. So in this case, we have 3 coefficients, and I'm going to put those 3 coefficients here, and I'm going to multiply those 3 coefficients together. So I have negative 3 times 2 times negative 4. And to solve that, this would become a negative 6, and negative 6 times negative 4 gives me a final answer of 24. So I've taken all the coefficients and I've grouped them together and solved. Next, I'm going to take all the x's. Right? Because I'm multiplying, the powers can come with. They're not different values, they're not different terms. So I can group this idea. I can take x squared times, I'll even change colors, right? X squared times, we got an x here, and then times, and we have an x here. Like this. We don't have to call this negative x because we took the negative right here. Just like we don't have to make it negative 2 because we took the negative when we took the 3. But in the end, we come away with this idea. Now we can solve this. We know that x to the first is the same as, x is the same as x to the first. And we also learned already this year that when multiplying by exponents, if our base stays the same, so x, it's going to remain the same. And from here, we're going to add our exponents. So 2 plus 1 plus 1 to get a final answer of x to the 4th. From here, then I can take my last value. I have a y. There's no y in our second term in the 2x, so we don't have to do any multiplication there. And then we take our final y here. And so we have a y times a y. And of course, we've already looked at this idea of y times y. It's the same as y to the first times y to the first. And we come away with y squared. And so in the end, as we break down our pieces, now we're going to join everything together into one fluent term. So we have 24 x to the fourth y to the second. Normally, as we put these together, we usually do them in kind of an alphabetical order. That just seems to make logical sense and visually makes more sense in our heads as we do that. And so we come away with this sort of answer. Let's try another one. So we'll do this one together, and then we'll give you one to do on your own. So as you break this down, we're going to take a step by piece. I'm going to start finding my coefficients, right? Here's my -2. Here's a 3. There's no known. We could say this is a 1 here, an understood one, but anything times 1, it's not really going to change anything. So I'm just going to kind of skip that. Now, if this was a -a, that would be a little bit different, but it's not, so we don't have to worry about it. So that's going to be my first grouping. Second grouping, I'm going to take my A's. I got an A, and no A. So I just have A times A squared, right? We're going to include this with our A. And so that's my second grouping. And then my third grouping is going to be my B's. So I have B, a B, and a B to the third. So B times B times B to the third. And then, of course, we're going to do our math. Okay. 2 times 3, sorry, -2 times 3 is going to yield a -6. A times A squared is going to yield an A to the third power. And finally, B times B times B to the third is going to leave us with a B to the fifth power. And so as we put those all together then, we have 6A cubed B to the fifth. All right. Now I'm going to launch you into your sample problem. If you need a little extra help, rewind, watch the first few examples, see how the steps are done as you jump into your sample problem. So here's our sample problem for lesson 87. And if you have questions, come ready in class and we will answer all questions. That's it for 87.